I think there's your extra credit. I think this one is your extra credit, is it? You can take a look. Let me take a look. Give me 1 second. Am I recording? Phosphorus 32 is a radioactive substances, and it has a half-life of 14.2 days. If 100 grams of this substance are present initially, find the amount after T day. What amount will be left after 7.1 days? Right. So there are two parts of this. First, we have to construct a exponential model for this, right? So let me write out the formula. Is decaying, so it's QT equal Q naught times e to the negative, I forgot what letter what I use, a negative K T. I forgot what letter we use. Different class, we use different letter. K, okay, we use K. So in this K, negative K. We have the initial amount, right, which is 100. So my model is a function of T, function of time. The initial amount is 100 grams. E is E, negative. Do we have K? No, we don't have negative K, right? Let me use negative K in all black. Negative K. And it's a function of T, so usually T it is, kind of like a function of X. So now I need to find K. Or rather negative K, right? You can remember the formula for half-life. Remember that one I'm not giving you. That one you're supposed to either construct it from scratch or memorize it. I'm not giving you that one. I'll give you this one though. So you can remember that or be what? Go back here. Let me construct right here. ln of 0.5 divided by h. So recall the formula is negative K equal ln of 0.5 divided by h, where h is your half-life, right? Half-life time. So in this case, h is 14.2 days. So ln 0.5 divided by 14.2. Maybe I'll leave it like that. I'll leave it like that. All you have to do is plug it in. 100 e to the ln 0.5 divided by 14.2 times t. And you look at K and like, oh, it looks positive, right? It is not. Remember the argument of log, if it's between 0 and 1, you can have negative log. So you plug that in your calculator. Plug this in your calculator. Let's see, ln 0.5 close parenthesis divided by 14.2. I got negative 0.04. So this equivalent to 100 e to the negative 0.04. I'll route to 4 decimal places. 88 t. That is your Q of t. So far, so good. What amount will be left after 7.1 day? That means they asking you to plug in 7.1 for t. So be 100 e to the negative. I'm gonna use the ln. The ln. You can use either one. I like to use ln 0.5 divided by 14.4, 14.2, because I lose less decimal that way. times 7.1. But it's easier for you to use that, it's fine too. 100. I'm going to show you how I do it so you see it clear. So 100 second ln plus e to the sum power. In this case, the power is fraction, so alpha frac. Right? So I have ln 0.5, arrow down, 14.2, go over, arrow to the right, 7.1. Was it 7.1? Was it 7.1? So 70.7 grams left. Something wrong. I'm expecting 50 grams. I'm expecting 50 grams, so if that's half-life. I got my phone. What did you guys have? .7 grams. You know, okay. I'm sorry. Yeah, half-life 14.2 days. You're right. We are right. I'm sorry. No, we are right. Nothing wrong with it. Expect something like this on the exam. All right, so that's exponential function, decay and grow. Now we go to a new function. It's called learning curve. So here is the function of the learning curve. Qt equals c minus a times e to the negative kt, where c is your limit grow. C is your limit. See, the function never crossed y equals c. A is your y-intercept. A, C, and K, they all constants. CA usually given to you. K, you have to figure it out yourself. Sometime it's given to you. Let's take a look at the example right here. An American court reporting institute find that the average student take advanced machine shorthand, an extensive 20 weeks course, progresses according to the function this. So this function, if you would have distributed out, let me distribute it out, because it doesn't look like the one I gave you, isn't it? It was a c minus a times e to the negative kt. It doesn't look like it, but if you distribute it out, 100 times 1 is 100, and then add to 60 is 180. Right? Minus 100 e is the negative 0.05 t. So now it looks like it. So all I do is to distribute the 100, then combine the 100 with the 60. So it is learning curve. What is the beginning shorthand What is the beginning shorthand speed for the average student in this course? Oh, let me refinish the reading, sorry. Where QT measure the number of words per minute of dictation that student can take in a machine shorthand after 2 weeks in the course. Sketch the graph, you can use your graphing calculator. What is the beginning shorthand speed for the average student in this course? Remember, Q of T is the speed. Yes. Go.
You asked me a question about where 180 came from.
Oh, I distribute 120. You see, I have a little arrow there. 120 times 1 is 120. Then you add it to 60.
Oh,
Yeah. T is time. Q of T is the speed, which is just the rate. So what is the beginning shorthand speed? Beginning means T equal what? 0, right? Beginning means T equals 0. So all you have to do is plug in 0 for T. So Q of 0. Oh. It's not doing anything. Q of 0. So 180. Maybe I'll use black for whole thing and then 0 for red. Because I wrote the function in black in the first. It's gonna be 180 minus 120 is the negative 0.05 times 0. I hope nobody taking out your calculator at this point. 0 to the 0. Anything to 0 is what? 1, right? 1. Yeah. So we at learning curve. So we finished one of this, which is you missed. So we stopped here last time. Here we just did it a few minutes earlier. We learning a learning curve. So that is 1. That's part e to the whatever that power is, but because multiply to 0, e to 0 is 1. 120 times 1 is still 120. 180 minus 120 is 60. Don't forget your units. Yeah, that's 1 point. Unit will be what? Words per minute, right? WPM, word per minute. What shorthand speed does average student attain halfway through the course? Halfway through the course, so how many days are there? How many days, how many, halfway through the course? That's 10 weeks, right? But the course is 20 weeks, so halfway through the course be 10 weeks. So all I have to do is plug in 10 for T. This problem seems to be a very easy problem here. Ten weeks equal 180 minus 120 e to the negative 0.05 times 10. This one you need calculator. 180 minus 120 e to the negative 0.05. Make sure you use the opposite key, not the negative key. Right, otherwise it'll give you error syntax. 107. So after 10 week, somebody, an average person can read roughly 107 words. I'm gonna round down, it's 107.2, but I'm gonna round down per minute. So it's much faster than they start out in the beginning, right? It was 60 and now over 100. So it's getting better. Will they keep going like that forever? No, right? You can't, right? At some point, you just take it fast you can, right? That's why there's a limit. Y equals C there. You never cross that line. Right? There's no infinite values here. How many words per minute can an average student take after completing the course? So after 20 weeks, completing the course, and they finish the course after 20 weeks. See how fast they can read now. Q of 20. On the exam, if you round up, I'm probably not going to take point because if I didn't specify anything, it's up to you. But, it's not important. Important what I know how you do it. All right, so let me show you how I do this. Calculator. 180 minus 120 e to the. Make sure you use the opposite key, right? Not the negative. That's two different things. Using this calculator. So opposite 0.05 times 20. Oh, something wrong.
You
Oh,
put
sorry.
0.005.
Yeah, okay. All right, let me show you a trick that I do. I don't want to retype all that. Press second, enter. So it means it's pull back, it pull up the last entry you had, right? And then you fix it. Delete. All right, it's better. It makes more sense, right? After 20 weeks, it's supposed to be slightly faster than 10 on average. So after 20 weeks is 136. Roughly 136. Word per minute. How fast can you type? I'm a slow typer, mostly because English is my second language. Right? So I guess my brain works different way. I can type 30 words per minute. That's low. That's very slow. My in statistics class, I make students type, and then I record how fast they type because they have to create a data set. The fastest one I had was 120 words per minute. That's fast. On average, will be roughly 60, 70, maybe 50. Yeah, around there. But I'm the slow end of it. I'm a like outlier. Like Mimi, you make our data set look bad. Okay, just exclude me. Yeah. All right. Yay, we done the learning curve. That's the example of it. Not too bad. Logistic growth functions. Logistic function is a special case of, I don't know which one is special case of which, but it's kind of similar to exponential function. It's grow fast. The only difference is at certain point, it's level off. So you see on the news, they say population growing exponentially. Not true, right? right now it is, right? But at some point in the future, the population had to level off, right? Either they run out of resource, right? We don't have enough resource, people, die off. So the population level off, or we can come up with a solution where we control the population, right? So either way, it'll level off, right? Because we only have finite resource. And that's logistic growth. Right? It grows fast at first, and then at some point it's level off like that. Same thing with, say you got infected with COVID, right? Do you guys remember the first day when you heard Michigan got infected with COVID? Like 2 people, right? 3 people, and then the next day, say 10 people, and then the third day, all of a sudden, 20 people, and then the fourth day, it can come to 100 or even close to thousands, right? So it's grow really fast at first, but at some point, when everybody get infected, it's level off. Right? Eventually, everybody will get infected. I don't know how many percent of population infected now. Last time I know it was 65%, and that's almost 2 years ago. I'm pretty sure it's like 90-something% now. I don't know anybody who is not infected yet. If you haven't, good for you. I don't know, good or bad. All right. So that's logistic growth formula right there. With A is your growth limit. It means if I have a graph like this, then A is my horizontal asymptote. Y equal A. That's why it's called growth limit. You never pass that point. It's just at some point it's level off. B is a constant, usually is given. T is time, Q naught is initial amount or initial number of people infected. QT is the current amount at time T. K is a it's a constant, not growth constant. I'm sorry. Yeah, it's just a constant. I wouldn't say it's growth constant. Just leave it as is. All right, let's take a look at. So there's their graph. Let's take a look at this example. Spread of flu. The number of soldiers at Fort MacArthur who contracted flu after Tuesdays during the flu epidemic is followed by this model. It's a logistic model. If 14 soldiers contracted flu by day 7, then this question kind of weird. I think I typed it wrong or something. Pretty sure I typed it wrong. Oh, okay. No, I don't type it wrong. It's supposed to be one question altogether. There's no B here. Kind of connected. Sorry about that. If 14 soldiers contracted the flu by day 7, when will 3,000 soldiers have contracted flu? The flu. Okay, so my deal is that what is my ultimate question I want to answer here? You're gonna understand you're gonna know what you're looking for first, and then you kind of go back, like what do I have, what do I not have it? Right? So what's the ultimate question am I answering here? Is it time or number of soldiers being affected?
Time.
Yeah, right. When they're asking you when you're home, right? So when, right? Time. So we're looking for T. T of what? I'm looking for T. Q of T is your number of soldiers infected, right? So when there are 3,000 soldiers infected, what is that time? So 5,000 divided by 1 plus 1,249. That's my B. E to the negative. Do I have K, or rather negative K? No, right? T I'm looking for. The one in red is the one I'm looking for. That's the when. But the thing before I can solve for T, I need to know K. Right? I need to know K. So now we're looking for K. So last problem. Wow, last problem. Okay. All right. Now let me write down here because I need that space. Now I need to look for negative K first. Usually I don't detach the negative with the K. You can, but later you have to put it back. So might as well just leave it there. What information I haven't used? What information? No. What information I haven't used? They give us something. They give us a piece that I haven't used yet. And then 7 days, right? I haven't used the 14 and the 7. So I have to use it somehow. That's the piece that we're going to use to solve for negative K. So 14 social, that's my QT. Let me rewrite the formula. QT equal 5,000 1 plus 1,249 e to the negative KT. That's the formula. The information that we have for in 7 days, there are 14 soldiers got infected. That's my point, right? There's my T, 7 my T, and then 14 is my Q of T. All you have to do is plug it in. Equal 5,000 1 plus 1,249 e to the negative K, and then T here is 7. Let me do yellow. You're like, how am I gonna solve K? Right? Well, one step at a time. Don't worry, one step at a time. Usually I write my 14 is 14 over 1. I have one fraction on the left, one fraction on the right. I can crisscross multiply, right? Or you can do LCD, but let's do crisscross multiply. It just looks easier. So 14 times 1 plus 1,249 e to the negative 7K. I can do, let me do negative K and then 7. Keep the negative K separately. Equal 5,000. So far, so good. Negative K times 7. Yeah. Divide both sides by 14. Whichever you want to do first. Either distribute and then subtract, or you divide. Let's distribute, and let's distribute. Maybe it's easier that way. There's no wrong way. It's just whichever way is easier for your computation. So let's distribute 14 plus 14 times 1249, 17,486 e to the negative K times 7 equal 5,000. Now I'm subtracting 14 both sides. 17,486 e to the negative K times 7 equal 4986. That's just easy arithmetic. Divide both sides by 17,486. 17,486. The left-hand side has cancel. So leave me just e to the negative k times 7 equal 4986 over 17,486. Leave it like that. Don't leave it fraction. Just leave it like that. How do I solve for how do I bring down the negative k? We did this last time. Take what both sides? What cancel e? ln, right? So ln both sides. That cancel. Go back here. So negative k equal ln of 4986 divided by 17,486 times 7 2, sorry, I forgot the 7. Negative k times 7. Multiply both sides by 1/7. I would suggest multiply by the reciprocal instead of divided by 7. It just sounds easier that way. So multiply both sides by 1/7. I have negative k equal 1/7 times ln of that block. That's quite a constant. You know what? I'll show you my trick to calculate this one without have to, worry about too much errors. I'll wait for you to finish writing that down. All right, so you got your negative k. Now you can go ahead and plug it in. Oh, good God. All right. Here's our dilemma. We're gonna solve another exponential function again. Do not plug in negative k right now. The reason being because it's too much writing, right? Just leave it as is. Just solve for t first, right? Let's solve for t first. Leave negative k as this letter, right? We'll plug it in at the end. So we solve another one. You know what? Why don't you guys solve for this? I want you to solve for t, like I did exactly like I did down here. Solve for t. My first step was I write 3,000 is 3,000 over 1. Crisscross multiply. I'll walk around, see how you do this. Show me some steps. Show me everything, but let me see some steps. Yeah, solve for t. Solve for the red letter. Negative k is no. We just solved it. I haven't plugged it in because I don't want to. It's too much writing. We plug it at the end. What? No, we solve for t. Right now, we're solving for t. In mathematics, I understand people understand what I'm talking about, but it's the first step would be cross multiply, like I did in the step below. So 3,000 times 1 plus 1249 e to the negative kt equal 5,000. Slightly different. I'll divide both side by 3,000. Or you can add, it doesn't matter. Your answer should be the same. So divide both side by 3,000. Like that. That's gone, right? So I have 1 plus 1249 e to the negative kt. Again, let me remind you, we have negative k, right? We just solved it. I just don't want to rewrite it. So I just use negative k for now. Equal 5/3. Subtract 1, 1249 e to the negative kt. If you subtract 1, 1 is the same thing as 3 over 3, right? 5 minus 3 is 2, so 2/3. Divide both side by, or rather multiply both side by 1 over 1249. 1 over 1249. 1 over 1249, like that. E to the negative kt equal, see, 3 times 1249 times 30, so 1 over, I'm sorry, 2 over, the top is 2, the bottom is 3747. And then take ln both sides, right? ln and e cancel, so negative kt equal ln of 2 over 3747. Remember we solve for t. Multiply both sides by 1 over negative k. That's true. Maybe I'll put the negative down here, like that. Right. On the left-hand side, that's and that cancel. On the right-hand side, you plug that k you know earlier, which is something quite awful as well. 17 ln, I write the negative k in black. 4986, and then 17486. Remember, this is negative k. You want the reciprocal of negative k, right? 1 over negative k. I'll do like that. Or you can put 1 over, right? It's the same thing. 2 over 3747. That's my final answer. Imagine you go to the bank and they give you that amount of money. What the heck? All right, so let's plug in the calculator. We'll take a picture and then I'll do it with you. So I don't have to go back and forth. Ready? Last time we can, I'll do this first. So frac. I'm gonna do the k first. So frac is 1 over 7. Alpha frac 1 over 7. And then ln. And then I need to frac again, right? 4986. 17486. Press enter. That's your negative k. Do you want that one or you want the reciprocal of that one? The reciprocal of that one, right? So what you're going to do is you're going to press x to the negative 1 right here. Just press that button. So answer to the inverse. I'm sorry, no, not inverse, reciprocal. Right there. And now you multiply with the blue part. So multiply that answer. Oops. Not yet. ln first. ln alpha frac 2 over 3747. So 42, roughly 42. We'll see what the unit. 42. See how fast it's infected? 42 days. That's more than half a soldier in that group. Start out with what? Remember, A is your limit, right? That's 5,000 soldier A. That's all of them. After 42 days, the 3,000 got infected. Remember, 14 days only. After 7 days, only 14 students. 14 soldier. So did you see exponential growth at first, right? Let me one more thing. I'll let you go. I'll ask you something. If I were to replace t with infinite, with infinity, what do you think? So eventually, 12, 4, 9, e to the negative k times infinity. Negative k times infinity is negative infinity, right? E to the negative infinity is what's no. What's e to the what e this part right here? So this is e to the negative infinity, which is equal to 1 over e to the infinity, right? Which is equal to no. What's e equal? 2.7 something, right? So 1 divided by 2.7 something is really small, right? And then if you power that, it's gonna get even smaller. Like if you have 0.5, if you square it, it's gonna even smaller, right? 0.025, right? So eventually, if you get to infinity power, it's gonna be 0. So that part in curly bracket is 0. 1,249 times 0 is 0. So 5,000 over 1. So eventually, everybody get infected. 5,000 soldiers, right? You know what I'm saying? Hopefully, maybe it'll help you on the bonus. But all right, yay! We finished the section. I'll keep you posted what happened on exam 2. I'll tell you what section to study. In the meantime, have a wonderful break, and most of all, be safe. Sure. Yeah, I can reopen the actual. I'll even open it.